Good morning, good afternoon, or good evening, depending on where you are in the world. Excuse me. What we're going to be going over is lesson 9 of what I've learned about basic electronics. If you haven't seen the first 8, I do recommend that you watch those, as this is a cumulative and foundationally building course. So, with that said, let's get started. As I said before, we're talking about solar power. Now, solar panels are made up of a number of solar cells wired together in series to increase the output voltage. You'll need a solar panel with an output voltage that is greater than the battery voltage. The diode D1 is essential to prevent, in this diagram, as you can see the diagram here, is essential to prevent current from flowing back through the solar panel and damaging when the solar panel is not illuminated enough for its output voltage to exceed the battery voltage. So as you can see, it comes in, and the voltage comes in through the current. The current is directed, goes to resistance, has an output, and that is the basic flow. Now, when we calculate that is the calculation of a solar panel is described by the following. That is, you start by calculating energy use of your project. In this case, capital W subscript S in terms of joules for a 24-hour period, because 24-hour day will include both the daylight and the nighttime parts of the daily cycle. The power consumption, therefore, is 70 milliamps times 5 volts, which is 350 milliwatts. So we basically have amps, which is wattage, which has to do with power. You multiply that by voltage. Now the energy consumption is 350 megawatts times the number of seconds in 24 hours. So if you do that math, that is 350 milliwatts times 24 times 60 times 60 equals 30,240 joules, which has to do with energy. Now that is capital P solar equals energy, capital E divided by capital H times 24 times 24 times 60, where E is the energy needed, as in 30,240 with this example, and H is the average number of hours. So what you do is you just plug it in. Energy divided by hours, and then unit of hours is times 24 times 24 times 24 times 60. Okay. Now, in terms of storage capacity, we measured in milliamps per hour, denoted by capital C, which can be calculated through this formula, which is capital C battery equals capital E divided by capital V times 60 times 60, 60 seconds in a minute, 60 minutes in an hour, equals 90,720 divided by 50 times 3600, give you 5 amperage hours. Now, using a load resistor attached to the solar panel, measure the voltage across the resistor to calculate power output. Output power from the solar panel P is calculated as in power equals voltage squared divided by resistance. Why? Well, we have a power output, and we have voltage coming in, was voltage 1 times voltage 2, technically. We're going to square that, so voltage times voltage, meaning voltage 1 times voltage 2 will give you voltage squared, divided by the resistance. Okay, because we're limiting the current flow through the circuit. So if you use a 1000 load resistance and the voltage is 5 volts, the output power is what? Well, again, we formally look at the equation. That is, power equals voltage squared divided by resistance. Therefore, in this case, is 25 divided by 100, which is 250 milliwatts. Keep in mind that the value of the load resistor needs to be low enough that the maximum output power of the solar panel is not exceeded. Otherwise, the solar panel will not generate as much as it could. Now, to calculate the maximum value of resistor, so if your panel claims to be 20 watts at 12 volts. An ideal resistor would be the same formula. So we would take the same formula, watts, wattage. Now we take the 12 volts, we square it, divided by whatever our resistance is, and that will give you what that is. And that is the gist of a solar panel. Now, what I also learned was some applications which I didn't include, which is measurements you can use with an in-between device that connects to a computer. And there's other things in which you could measure it with. Sorry, that was from the previous lesson. So that's the gist of it. All right, not too difficult. Just the main idea is we look at the schematic diagram. Power going in through a diode in terms of current. So the diode will control the current going through resistance and then an output. Basic stuff, right? Remember that our power P solar is going to be based upon our energy, right, divided by the average of hours. So over time, and then battery, which is the storage of energy, is going to be energy divided by voltage times the time, which is H, which is 60 times 60. And then of course we get 5 amperage hours. Remember, this would be storage of energy over time. And also don't forget our main formula, which is power equals voltage squared divided by the resistance. Remember that power, this is the output power, so technically we could actually do this in reverse, where we would come in with voltage 1 times voltage 2, right? So that would give you your squared, and then we get a resistance, then we get the output. Okay, so that's basically what it is. Okay, so that will do it for this time. Okay, don't forget how these symbols work, because this has to do with a diode, this has to do with resistance, this has to do with output, this has to do with the flow going this way in terms of our current, and this is the actual input in terms of power. Alright, so I'd like to thank you for taking the time to watch these videos. You could be watching any other electronics videos, so I do appreciate that, certainly. While this did provide value for you, that you were able to learn some basic things about electronics, especially if you'd like to have a review, or learn more about it, in this case, the solar panel. What I'd like you to do is please click like on the video. That way I'll be pushing the algorithm, more people will be able to view it and enjoy it. If you haven't already, please click subscribe on the video. That way you'll have access to all the content on this channel, as I do have a variety of subjects on this channel for you to benefit and learn from. Also, if you haven't already, please click the bell button. That way you'll be notified of all my future videos, as in whenever the new videos come out, you'll be notified accordingly. So I'd like to wish you a great day wherever you are in the world. Take care, and I'll certainly talk to you next time.